All right. So those are the ideal things that we would like to have. Yeah, sadly, those are not always achievable. So let's talk about what works and what doesn't. Ease of computation, sure, no problem. That's not a big deal at all. Easy, easy, easy. Addition, subtraction, multiplication, as long as I use operations that I know are fast, ease of computation is no big deal. Fine, no problem. Easy, easy. Pre-image resistance. Yeah, getting a little harder. So we have some functions that are hard to undo. Remember, pre-image resistance is basically it's hard to undo your hash function, right? Given the output, it's hard to find the input. So we could play with this. It's not horrible. We'll do an example and we'll talk about whether or not this has pre-image resistance. Kind of, sort of, not quite as easy as ease of computation, but kind of, that'll work. Strongly collision-free, this one's hard. This one is really, really hard to achieve with hash functions. It is not an easy thing to come up with. So, as cryptographers, we have two choices. We can either say, okay, strongly collision-free is very hard to achieve, and therefore I'm not going to have any hash functions, and today's class and Wednesday's class are done because we can't come up with this practically. And as tempting as that sounds, that's probably not a good plan. So instead, what we're going to do is say, I don't like this, but let's relax our requirement just a little bit. So we're going to instead settle for something called weakly collision-free. Here's what weakly collision-free is. If I give you a message, it's hard to find another message that hashes to the same value. We're going to talk about how this is different from strongly collision-free in just a sec. But given a message, it's hard to find another message that hashes to the same value. So given M, it's hard to find M prime so that both of your hashes are the same. Okay. Strongly collision-free says it's hard to find two messages that hash to the same value, starting totally from scratch and finding two messages. Weakly collision-free says if I give you a message, it's hard to find another one that hashes to the same value. So that's how strongly and weakly collision-free are different. Okay, makes sense? Is that the difference between those? Daniel, does that answer your question? Good. Okay, cool. All right, this is sometimes called second pre-image resistance. Sometimes weakly collision-free is also called second pre-image resistance. That's what this is sometimes called. You have a function, you're trying to find another one, another pre-image that hashes to the same thing. So sometimes called second pre-image resistance. Okay. Questions up to this point before we talk about where we might use hash functions? Anybody, anything up to this point? All right, then I am going to make you talk to each other. So I'm going to divide you up into breakout rooms. Here's what I want. See if you can think of some places, and honestly, if you're computer science, you probably have an advantage here, but that's all right. See if you can think of some places where you would want to use a hash function. When would it be useful? When would it be helpful to take a message and basically shorten it? Get all the same information that you have in the message already, but make it into a shorter version. Okay, so take a couple minutes. We're going to try this. We're going to divide you into breakout rooms and have you talk to each other. Breakout rooms. Let's do 4 rooms. Okay, you should, I'm doing this automatically. We'll see how you get divided. You should get an invite to go ahead and join breakout rooms. So go ahead, see if you can come up with a list, and then I'll bring you all back together in a couple minutes.